All right, so yesterday we did some predicting on these reactions. Now, I think if you look at your observations today, you're going to find that some of our predictions are not right, okay, based on kind of what happened in each reaction. So for example, in pair 1 yesterday, we said this was going to be a double replacement reaction and that the two metals were going to swap. So we were going to have ammonium hydroxide and sodium chloride. Except what happened in that reaction? Today when you did that, what was your observations? Or what were your observations? A strong odor. Okay? A strong odor should have been detectable in that one, like really strong. Which means what was produced? A gas. Okay? Are either of those two compounds, since they're ionic, gases? There are no gaseous ionic compounds at room temperature. So this prediction isn't right. Okay? What we have to do is figure out what really happened. So I'm going to give you a little bit of it and kind of help you to get there yourself. So you might want to write these little hints down. Okay? The gas that was formed in that reaction is ammonia, NH3. It's the stuff that's in Windex. All right? So if you kind of think back to what that smelled like, it would smell like really, really strong Windex. Okay? So I know that one of the products was this gas. There are two others. There are two other compounds that were produced. Here's how you're going to figure out what those other compounds were. Where is the most likely place for this NH3 to have come from? Right, from here, right? So if I get rid of that NH3, what does that leave me here? H and Cl. Okay, so really then, what we're saying is if I take that away, this is what's left. Can I figure out a double replacement reaction that goes on between those two compounds? Okay, that's what you need to do. The other two products are the products of that reaction. Okay, figure out what the other two products would be based on what's left after the ammonia has been removed. Okay, so you guys will have to figure out what the other two compounds are and then balance the reaction. Now, in pair 2, we had a similar problem. Yesterday we said this is a double replacement reaction and sodium and hydrogen were going to switch places. And that was going to produce two ionic compounds. Except, what does vinegar and baking soda do when you mix it together? It bubbles and fizzes, which means it's producing a gas. So again, we have a prediction of two ionic compounds and observations that don't agree with that. The gas that's produced in that reaction is carbon dioxide. Okay, where's the most likely place for the carbon dioxide to have come from? Yeah, from the second one, from right here. All right, so if I eliminate the C and two O's, I'm essentially left with this. Right? Once I eliminate the carbon dioxide, can I do a double replacement reaction between those two things? Okay, keeping in mind that even though this is written this way, it's really this compound. Right? This being the metal and this being the non-metal. Right? That should help you get the other two products of that reaction, then balance. Okay? The other ones should have gone pretty much as predicted. Okay? So what you need to do in your analysis now is write out these reactions in formula form, write them out in words as well. Okay, so for analysis question number 1, what I should see is a chemical reaction like this, and then a word reaction, and then the same thing for number 2 and for number 3. Okay, you do not have to do those two. Right? So in the analysis, don't write anything for 4 and 5. Okay, you don't have to write those reactions. 1, 2, 3, 6, and 7. Okay. Question number 2 in the analysis, remember, is a solubility question. All right, so look at the products that you make in your reactions and see if any of them are soluble, which one would be the precipitate, etc. All right, is that ringing a bell from yesterday? Okay, so I'm recording this. I'm going to post it along with the lab. I also already posted my observations video. Okay, so if you want to double check and make sure you got the right observations, you can double check by watching my observations video, okay, just to make sure. And then you'll have this as well to remind you of how do I get the reactions done in analysis question number 1. Okay. Any other questions there? All right, so I would say probably not a bad idea right now. Maybe sit down with your group and see if you can figure out some of these reactions in the 10 minutes or so we have left.